Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, we're going to get started with the next session. Next up, we've got the Texas A&M team with Andruid Kern, Andrew Webb, and Alyssa Valdez. And they're going to share with us what they've been up to most recently. And let's all give our attention to the folks at the front of the room. Thanks.
Cool. Good morning, I'm Andruid Kern, and this is Andrew Webb and Alyssa Valdez. And we're going to talk about collaborative design ideation with pen and touch.
So design is a purposeful process whereby which a means to an end are laid out. It involves a conversation with materials. Those can be both physical and digital. Designers go through this process of they reflect on ideas, they then draw, sketch, and create representations, and then look at the things that they've drawn and reflect on ideas more. So it involves this process of creating external representations. We're particularly interested in early stages of design where they create these more abstract representations or diagrams, sort of like these the examples here were by the architect Bernard Schumi. So the idea is that the representations are very, they support multiple interpretations. They're flexible, and so it supports creative processes by letting you interpret it in different ways. And design involves both individual and collaborative activities.
Yeah. Maybe not.
So is it coming off your laptop right now?
Yeah.
We could just move it.
You really think that? But we need to be able to switch.
That's fine. It's an app.
We can switch sources pretty easily.
Okay. Sure.
Come on.
Okay. Here I am over here. Yeah, I guess I just wanted to say something that's obvious, which is that we draw kind of more explicitly from the arts in our approach than most of the people here. We do a lot of science too, but yeah. So this relationship, this notion of ideation and its relationship to media. Ideation means the process of generating, imagining, developing ideas. And the notion of medium is really an art-based notion, but Marshall McLuhan kind of famously addressed it in the 60s. And one of the things that he said is that the message of any medium, the medium of the message, if you will, is based on the change of scale, pace, and pattern it introduces into human affairs. Scale, pace, and pattern. And so there's this history of media, starting with cave paintings, through writing and various electronic and then digital forms. And so the question is, what is next in terms of media? And yeah, and so we certainly think that non-linear media are going to be more important than they are so far, and that society is very print-based, even though we have these devices. Print being a very linear medium that let us do other things. Okay. In our 2014 Tukai paper, we developed this notion of information-based ideation and connected it to this idea of curation. So again, it's ideation, the generating, imagining ideas, but this explicit role of information as stimulus. It involves a very wide range of personal and professional activities. It's very important in a very wide range of activities, but it's also far from everything that people do with information. And I mean, I think that I'll just mention there's a sort of epistemological tension, as far as I'm concerned, between the notion of analytics and ideation. Because analysis is great, but ideas don't just come from analysis. They come from seeing relationships. It's important to mention Marcel Duchamp's seminal work at the beginning of the 20th century with found objects and the fountain where he took this urinal and he labeled it, and it's the only thing anyone remembers from that exhibition, right? It's the only piece that anyone remembers. And so this notion of changing the context of something and labeling it, changing its metadata, changes the meaning of things, is significant. It's important. We developed this work that we called information composition, that was working in this art-based notion of putting things together to create a whole. And the role of visual as well as semantic elements. And so recently we're extending that with sketching and multi-scale interfaces to develop what we call free-form web curation. And so curation is a creative process of choosing, organizing, and sharing. And I do think that what people are doing now with Facebook and Twitter very much is a kind of curation. But there's an aspect of curation that comes from the arts that's about intentionally creating context, and using space is a really key aspect of curation in the arts that's missing in linear feeds. Linear feeds have great qualities for keeping people up to date, but they're not very good for relational thinking and this notion of dimension, again, of like how people connect ideas together. So we've been working on this medium that we call free-form curation with a web orientation, and we have actually 3 different idea-maché clients at this point. I'm using the web-based one right now, and Alyssa and Andrew are going to show the fledgling Surface Hub one, and then we have another one, embodied maché, that Andrew's going to also show. The latter 2 being pen and touch. So this notion of free-form thinking, an emphasis on improvisation, exploration, associational thinking, and this is a way that people have new ideas. It forms a basis, because there's a lot of creative cognition, of cognitive psychology, that shows that it's when you relax your constraints and get away from the structures you know that you're more able to see things in new ways and have ideas. So free-form web curation, we specifically talk about spontaneously gathering elements, writing about them, sketching, manipulating, and this notion of visual thinking in a continuous space is really key. We've developed this articulation of these processes of free-form web curation, which we find are really important both in how we build software and how we teach people to do this and explain it to people. So the notion of gathering content from different sources and making that easy for people, letting them assemble it visually, and then annotating with sketching as well as writing. And then, okay, so shifting perspective is related to this spatial notion from the arts of like what happens when you walk around a gallery space. So letting people move around. And then the cloud ends up being really important in today's world. And so all of our idea-maché clients use the same cloud services, and that interoperability is really important to people because they can make things on our fancy devices and then show them in web browsers wherever they go. So we have a paper coming out in a few months about patterns of free-form Webb curation, and it's a field study of almost 1,600 students in 5 courses. What just did that happen here?
Oh, right here.
Here.
Yeah, it's about right here.
Thanks. And we came up with these major patterns of morphology, overlap, grouping, and paths, and then the minor patterns within them. How long have I been talking for? 10 minutes. Yeah, I should stop soon, so they can talk. And so we have all these pretty exciting examples of work that students have done in different courses, and I can show some of them briefly. This feminist hashtag activism, this is for a final paper in upper level communications course. And you can see how the concrete morphology of the looking like a Twitter feed was used here. And this one about scoliosis, where she has the concrete morphology again using the spine, but then also this one-dimensional plot here, an abstract one. And the range of information that she's putting together that's both kind of technical and personal about her experience of scoliosis. Catherine Kimmel. This is an entrepreneurial piece that involves developing an idea for an invention, and there's like patents and company information, and it's been put together in this integrated way. This piece is pretty interesting. Buildings made from old buildings. You can see how the sky is both natural and manufactured, but what's really interesting is how inside the outline of the building, there's this texturing of all of these old buildings. Oh yeah, and this sketching over here, which Andrew's going to show examples of, this is the morphology map pattern, where this physical geography is serving, drawing over it is serving to provide an analysis of coastal practices, coastal management practices. Okay.
So the input modalities for which which are supported affect the kinds of expressions that humans are able to create with computing systems. And so we hypothesize that the pin and touch supported by the Service Hub is going to be really powerful and effective for supporting visual designers such as architects. And so the way we perceive and interpret the world around us is through our bodies, and our cognitive processes and mental models associated with are also based on being in bodies, and so therefore our creative processes are also embodied. And so then the question is, so how can we use these sensing modalities that support capturing movements of the body to support design ideation? And so one of the things we've been looking at is allowing these sort of gestural interactions that allow designers to manipulate and transform visual media directly with their hands, and support these sort of exploration of diverse variations, so they can kind of play around and explore ideas. And so this is sort of beneficial to creative processes where you can look at a lot of different, a variety of different solutions. But then as we begin to support them in doing these complex set of different forms of visual transformations and operations, is how can we then have the system support these transitioning across these different modal operations. So one of the ways that we are looking at doing this is through phrasing bimanual interactions, through using an asymmetric division of labor between the hands, following Guillard's kinematic chain model, which basically says that the non-preferred hand provides frame of reference for the actions of the preferred hand. This is exemplified in, if we're just like working with drawing on a piece of paper, then we orient the paper with our non-preferred hand while our preferred hand draws with the pen. This has been exemplified in prior work by Hinckley et al., where they used pen and touch as a sensing modality to support these kinds of interactions. And then as part of an internship I did last summer, work that's going to be published at WIST, we further expanded that looking at how once we can use wearable devices to sense the hands, and we can also, we can then support that on collaborative surfaces where we have more than one person interacting. We can identify which hand each user is touching with and support these kinds of asymmetric bimanual interactions. So my dissertation research primarily develops one of the versions of idea-maché called embodied idea-maché, which supports freeform curation with pen and touch. So the idea is that you can gather and assemble visual media from the web, from personal devices, and compose those in an infinite zoomable space. They can annotate, sketch, and you can engage in these bimanual interactions that support various forms of visual transformation, like adjusting opacity, allowing you to blend together images, allowing you to perform perspective transformations, sort of exemplified here, allowing you to adjust the layering order of tens to hundreds of overlapping elements. So I'm going to show. So here we have a student working with embodied maché, a landscape architecture student. They're collecting images from the web about reference materials. They're also collecting text. They're working on this idea of pedestrian bridges. They're sketching sketching over things to sort of annotate their ideas. And they're using, let's see if it, yeah, so switch over. All right. Just actually edit this. And so here's another example of a student. This is a particular example of sketching over, where she is sketching over and perspective transformations. She's oriented these things in perspective, and now she's sketching and annotating her ideas on top of them. So as a context for investigation, we've been working in deploying embodied idea-maché in landscape architecture design studio education to support teams on their early stage design ideation. And so they've been working, they will come to our lab and use embodied idea-maché as working as individuals, and then they would come together and collaborate. And so they would collect images from the web, as well from their phones. In this particular example here, this is the students they came to our lab before going to Costa Rica and collected information about ecotourism in Costa Rica. Then they went there, took photos of sites, and came back, and then put their photos into their compositions, into the curations, and sketched over them, sketched out their ideas. And so then they also used their creations as ways as presentation in their design studio to their course instructor. So now Alyssa is going to talk about what we're doing right now with the Surface Hub.
So we have Maché Wall. It's software built for the Surface Hub. And so the Surface Hub with a really large screen and collaborative support for people. And then we have, these students who want to collaborate and do things together. So I'm just going to show a quick demo of what we have so far of this prototype. Our jargon kind of for these compositions is a maché, so that's how I'm going to refer it to. So I have this maché about pedestrian bridges. I'm going to zoom out a bit to get a better perspective of this composition. And so I can, pan around this maché. I can zoom in a bit, zoom out like that. And so I'm going to move over here and look at these elements. So they're all images. And so I can grab an image, move it around. I'm going to move this one a little bit this way. And you can also, scale them to make them bigger, smaller. And so this gives people the advantage of, being able to compose elements the way they want to. I'm going to move on over here, expand this a little bit. And another thing is, to annotate on these machés. And so this is a really old picture of some bridge, so I'm just gonna write old bridge. And so you see that little fade there? It's kind of just telling the user, hey, this ink is drying, and once it fades, I can manipulate it like I can with an image. So I can make it bigger and smaller, sideways, rotate it, whatever. So if I draw something, and I'm like, wait, no, I'm not done, I can add something else, continue adding, but if I'm done, it fades away and it's all one element, and I can erase it with the back of the pen. So I'm gonna zoom out a bit. I'm gonna move around. So I have the space over here. I think I wanna add some images. So I can add images from a USB that I can plug in. Let's see. There we go. And so if I use, one of the things is that we're gonna have different types of gestures. And so for me to pull up the pictures from that USB, I put 3 fingers on there, see if I can do that. And so I have this view of all these images. I want to give myself some space, move over here. And I'm going to drag in this image here and this image. And I'm just going to compose it the way I want. Do that. Move it around a bit and just annotate that. And this is a little piece of that. And that's how I can show that with my sketching. And so I've done all this work on the Mache, sketches, adding pictures, whatever. And I kind of want to, I don't have a Surface Hub at home. So I want to work on this outside of my workplace or collaboration space. So I can go, let's see. Oh,
Yeah.
Exit full screen. I can go on Idea Mache using our cloud services, and the changes I've made are there on the screen on the web version. So I can pull that up and go back to back. So now I'm going to invite Andrew to collaborate with me.
So that's interesting. So I have this idea. I saw there was this image. What was it? Oh yeah, this is one of these pillars. Sorry.
Yeah, that looks good. Move a bit this way.
I think this is a pretty interesting looking pillar here.
Yeah, I'm going to sketch over that. Actually, I'm going to erase that. I'm going to use a different color just to accentuate that. This is called a jutting pillar. And so I have this ink, right? And it says at the bottom I'm number 1. And so I have pink, and when he puts his pen, he has his own type of inking. He can change that or use whatever he wants. And we hope to add simultaneous inking with this too, and more gestures and other things so we can support the collaborative efforts for these students and these type of devices, large surface devices. And I think that's all I want to show today. Yeah. Yes. Okay, and so yes, we're thinking of putting simultaneous ink. We got support from that, thankfully, this week. And more gestures, especially with pen and touch, not just touch or just with pen. And clipping from the web and having data with that when you clip from the web. And other types of elements like videos and GIFs and other fun things.
Okay. Yeah. So, we just started working with Service Hub, as most people here have, but we're really excited about being able to support multiple users at the same time and multiple pen and touch gestures, and even just to be able to do pen and touch in Windows without fighting with it is a great step forward that's going to make our lives easier in developing this work. And we do have this really nice context to work in with landscape architecture students specifically, as well as the broader set of students working with idea mache. So we'd be happy to hear questions and ideas. Steve, then.
Have you thought about what happens when the multiple users are not co-located?
Yes, actually, we are working on in our web-based client, we're working on support for that right now, and actually, there's supposed to be an alpha release when I get back. We'll see if there really is, but it's coming really soon that we're going to have that. We've been thinking about it for a while, and the tensions between co-located and remote collaboration are really interesting.
Especially if you make it so you don't have to lock this part for only one person.
Yeah.
Lock that, as so many of those systems do right now, which is incredibly awful.
Yes. Yes, we're working on that. We're thinking about it, and I'd love to hear your ideas about it. Yeah. Hi.
You'd showed the web experience as well as the Windows 10 experience. If you were to make a change in the web experience, would that also be represented in the UWP, or because you made a change to the Windows 10 app that was reflected in the web app, is that kind of a poor man's collaboration, being able to have some synchronicity there?
As I said, we are actually working on the capabilities for doing simultaneous real-time updates and not having to do it that way. But yes, that's the way we've been doing it for the last 10 years. And by the way, of course, I did the presentation using our new presentation mode in idea mache itself as well. But yeah, like I said, being able to do those kinds of updates, we do certainly intend to. You need a lot of the same things on the back end for co-located and remote collaboration, even though a lot of the interaction is different. So that's fortunate for us right now. Dave.
Do you have a sense of what latency you would expect in this web? You know, if you make a change on one side, how long does it take for the change to show up on a remote client?
I don't, but I was talking to the Azure people yesterday about how they could help us make that faster. And maybe you could help me talk to them. That would be awesome.
All right, thank you. Oh, time for one more question.
Thank you. I'm curious, do you always, in this case, see the same tool being used for both the ideation and the creative process, as well as a presentation, a final presentation of those ideas? Do you place equal emphasis on both of those use cases for this tool, or do you see that being split between different tools?
That's a great question. I'm really interested in this medium as kind of a throughout medium, and I'm also interested in like direct relationships between it and linear writing. And we do think it's really useful, this being able to organize information spatially, conceptually, and then layering sequential presentation over that, because presentation is inherently sequential. And that is what I just showed. And that is also very new work that Feiyu Yu has been working on, been developing this. So I'm interested in this medium, but there are definite, across creative process ideation stages, if you will. But there are definitely going to be things that you want more for different aspects of it, different stages. So, how that differentiation washes out, I think will be interesting. But we've had a pretty wide range of different uses in the courses already, even.
Thank you.
All right, thank you, Temu. Yes.
All right, thanks for having me. I appreciate being here. I'm going to talk a little bit about our group at Georgia Tech and what we've got. To be safe, my presentation's a bunch of videos to make sure it runs. I've got 2 demos to try to run at the end. Hopefully they'll go all right. At the beginning, I want to situate things for a couple of minutes and where it all kind of fits. So I'm in the College of Computing at Georgia Tech. We're a college. We have 3 departments underneath. I live in the School of Interactive Computing, and I'm representing here today 5 of us that are now the visualization group there at Georgia Tech. Polo Chow was here this week, and there's one guy there who a few people in the audience know really, really well. So yeah, I'm representing all the different work that they're doing. Last summer, we moved. We all moved offices. And our building here in the Tech Square Research Building in the kind of upper left corner, our offices moved, and the big yellow thing is a visualization lab. So we got a visualization lab, and that is half of it, and you see the hub kind of sitting off on the one side there. That's a big multi-display machine, the other one. So I want to quickly run through 4 projects that we've been kind of spinning up this spring and summer on the hub. The first 2 are large. So I said we're data viz people. So the first 2 are largely bringing data viz to the hub and just seeing much like what Steve was talking about earlier. The first one comes from my colleague Rahul Basole. He works in business intelligence and business analytics. So he does a lot of network ecosystem analysis. He's built this system called EcoSite, and actually let me get it kind of running, the first of the videos. So in this system, they have a tool that scrapes and pulls and basically pulls a lot of corporate information from the web about how companies are agreeing, cooperating, competing. It's pulling things like press releases, certain databases, and his system, EcoSite, represents these relationships. He has multiple views, but kind of the natural common one is a node link kind of graph view. So what he has done, they had a version that runs kind of desktop initially, and they've brought it over to the hub. They are largely, I mean, as I said, it's not that different in how it runs there. You do a few gestures differently. But like Steve said, they're thinking a little bit about the consumers for this tool in many ways are CEOs. So the storytelling presentational angle gets amplified, and the hub seems a nice environment for that and kind of telling those stories as you interact with it. So Rahul and his group are working on this. They have actually brought in some corporate folks to kind of demo on it, and it gets the kind of gee whiz reaction that you might expect. The second tool I want to show is from my PhD student, Alex Godwin. And he has been working with Surface, but small Surface for a while. He's my first student who's doing geovisualization. It's a rich, deep area. People are doing a lot of work. But his particular focus, first on the Surface, has been sketch and pen. And the idea is something like if you are a city planner and you want to change around the police beats to see if you can optimize 911 call response time and things like that, wouldn't it be nice to have the natural interaction of a pen to draw geographic regions rather some kind of clunky user interface? So what Alex just did a couple of weeks ago with the hub was to bring some of his tools to the hub and to transition it. And let me get that one started a little bit as well. So this is 2 years of crime data from Atlanta. You first see the natural kind of heat map view that you get there. And what he's doing is kind of zooming out a little circle. On the right-hand side and the bottom, the data updates about the crimes within that circle. They're the type of crime, red or serious, black or not as serious. And then they're by day of the week, by hour of the day, by week of the year. On the bottom, there was a little view that when you make a circle, it's like how far out from the radius are the crimes? What's their density? This next thing is a view, if you want to draw a path, I want to get from here to here, I want to move along something in segments, you could set it up, and along the bottom, it'll show each segment and the amount of crimes that are occurring there along it. I'll let him go on a little bit further. The startup is a very natural GeoVis kind of kernel density heat map view, but he can change to showing the individual crimes. Okay, the red ones are serious, black are less serious, the bigger, the more recent. When you click on individual crimes, it'll take you down to a recent Google Street Map view. Okay, so one of our ideas, and we've started a collaboration a little bit with the Atlanta Police Department. So you could imagine the APD coming in and having a big hub and maybe just doing some back-end kind of exploratory analysis and view. A third one, kind of my area, what I work in, Infovis and decision making. There are a lot of data viz tools that you interact with, and the interaction largely goes through surrogates on the sides, widgets, controls, things like that. And we're thinking about different techniques where the interaction is a more fundamental part of it. Well, a number of years back, we developed a system called Dust and Magnet. The idea here, the little dots in the center are your data. Here it's cereals, breakfast cereals. The rectangles are magnets that are the attributes on your data set. Sugar, fat, potassium, sodium, things like that. If a cereal is high in sugar, that dot is drawn more close to it in a kind of magnetic pull. And this is a system now over 10 years old that we just had a little desktop kind of notion. And we wanted to explore kind of bringing it to the hub. So this is, I'm actually proud, this is a sophomore, an undergrad, it's not being shown here, named Andruid, who just did kind of a fairly quick port over. I have to give a shout out to Christopher because we're using his toolkit to do the touch. And the touch is a challenge to get all the gestures and pinches and things like that. And Christopher's group has written a toolkit. We've been using it. It's been really nice. And that's kind of what you'll see. Let me show a little bit of the video here. Get it. Oh. So this data set is, I think, the top 400 colleges by SAT score in the nation. And you bring out the magnets in this view are on top. So he's bringing SAT average down. And again, the individual colleges are drawn to it. So a little bit of a notion like Sandance in that the dots are the data, but a very different metaphor with these magnets. This system, multiple people can be interacting as much. And here he's amplifying. You can kind of crank up or crank down the magnets, which change the drawing force. Here I'm looking, I think there's like Berkeley and UCLA and some stuff to kind of try out. There are different modes. In one mode, all of the data repels each other, so you get less overlap. In another mode, they kind of take their natural positions. I won't run. I'll hopefully be able to demo this in a little bit. Then the final project I wanted to show just a little bit of is the workshop was entitled Visualization for Touch-Enabled Platforms. These are big ones. We've been exploring smaller ones a little bit too. I have to apologize. We've been exploring the iPad largely. My student Ramik has been doing some things with bringing Infovis to tablet. And in particular, this is just a paper from Euroviz looking at how do you do multiple coordinated views with different visualizations. The killers there, as was mentioned before, the fat finger problem and occlusion. Occlusion nails you because you go to interact and your hands are in front of the data. Another challenge on the iPad is typically one hand's tied up holding it. So multi-hand gestures, we generally stay away from, and we try to go as simple as possible. So I'll show a little video of this one. So this just four simple, kind of some standard scatter plot. Tune that down. And one of the ideas, as mentioned with Andy before, is what are the right set of gestures to interact when you want to do zooming, you want to pan, you want to do multi-coordinated brushing across. Zooming isn't always in both XY aspect ratio. You want to sometimes zoom on axes. You want to pick things. And our design philosophy is always, if you can do it in one finger, do it there first, maybe two. But we do not want to introduce complicated gestures because the learnability and memorability really become problematic. We bring in a data view, individual data item cases from the bottom, other things, and this is just some parallel coordinate stuff he did to kind of add it on. I'll skip past that. Another fun thing for us with the hub has been outreach. So this is a view, that's my PhD student, John Thompson. John summer interned at JPL, at the Jet Propulsion Lab last year, and he worked on the Mars rover project. They're designing new user interfaces for the rover. And this is a visiting group of middle school girls. We're promoting STEM and things like that, and the hub is a gee whiz cool platform for things along those lines. So we've been using it in that kind of outreach sense as well. We hope, the guy sitting over there on his laptop, to set up a monthly collaboration through the hub. So we have not used the business guy, the connectivity at all. I know Aaron very well, and we've done some similar things along our groups, so we're hoping to set something like that up in the fall to get going on it. All right, to finish up, let me try to do a couple of those I showed. We'll see if a couple of quick demos actually run here. I need to, I don't want to do that. End this.
I'd like to point out the view of the golf course that's just behind that.
All right. Let's see if this all comes in. So this is that crime data one, and it's, see if I'm connected. There we go. Okay, so Atlanta in general, serious crimes, non-serious. The big bar, larceny from vehicle. Okay, that's kind of the big one. Just kind of looking, but now you have to search some areas. So I'm going to do the circle tool, and I hope I remember. So let me pick a few areas of Atlanta. I know if I kind of do that, and I'm in that radius, I click on it. Yeah. There we go. So now it populates the data from that region. You're seeing day of the week, Wednesday, a little bit of a spike, hour of the day, evening a bit more, week of the year. And then this is the amount of crime in that circle, radius as you go out further. And anyone who knows, the radius, you get more area on the outside, so it's not surprising that it's more as you go in there. I can do other, I didn't do that right. Not my demo. That's kind of, to look at it, let me try to change over. I'm having trouble with it. I apologize. Change to, oh, it's just really, really slow. Well, I tried to change to the individual dots of crimes that are throughout, and kind of zoom in to a region. Zoomed in a lot. Select one to go down to the Google Street Maps kind of view to run it. And of course, there's some potential privacy and other issues here that are interesting. And I learned that there was a larceny from vehicle on December 10th last year and things like that to kind of get into it. Alex in his work is thinking about working with some local neighborhood public kind of units and how do they do kind of planning for their group and so on. And we're trying to run workshops with the hub along those lines. So let me end that one and try to do the next one. So this is the college, the dust and magnet one. See how it works. got to bring the data up through this. Okay, let's see if it works. All right, so that's the colleges. See how it's going. Yeah, University of Virginia, main campus, kind of there that I can click on. Now these are the magnets up top. So maybe I want to bring down, it always hangs up, the admission rate of different schools. I can, how about SAT average? Kind of bring that along the other side. And, come on. Got some other interesting, so average cost. It's got stuck. Kind of bring down as the different schools. You could start to interact, so SAT is a little bit more important. So I want to amplify that a bit more. Okay, so schools, high admission rate, kind of mid-cost. I've got University of North Texas, there's a Queens College, things like that. Got some filter things, so look at only those in New England, maybe private. There's a different, as I said, the mode. It doesn't seem to be processing, but there's a different mode where the particles all repel each other, so it's easier to read the individual items and move it. That doesn't seem to, there. Seem to get a little bit of it. But again, just kind of move around. We don't like this general kind of magnet metaphor as a broad global thing. The idea, our kind of next generation of this project, we like this notion of the individual data points as this. We're thinking about it as a data analysis tool for people who aren't data scientists or aren't so familiar. One of our ideas has even been, how does someone do analysis who's never run Excel before? Right, what is it all about? And what would those people bring to the table in terms of what they know? I think they could think about things like ordering or grouping, like put the public schools here, put the private schools here. And now I want to bring kind of an individual magnet and say, here's price, and just kind of sweep it across it, and they order in these subsets along those lines. So we're thinking about actually doing some kind of hybridization of this. We don't quite like this. It makes for an okay demo, but we want to do a little more with that. So yeah, so that's it. That's just a quick overview of some of the different things we're doing. I threw one slide in, a couple of kind of reflections to Microsoft and what we had. So we, about a month ago, we got an email from the local Southeast hub support tech guy saying, next Monday, your machine will stop working. The software will, yeah, and we're like, whoa. So he came in, he updated, and it's like he showed us how to use the machine. And it was amazingly helpful, and he was really good. He works with a lot of companies in the Southeast. That was fantastic. Unfortunately, almost all our students are away this summer, so we struggle with that. Second one, almost right away, we bought a big Windows 10 box, and we've hooked it up to it. We haven't done anything with the apps and the App Store kind of view. So we, for the collaboration work through Skype, we'll do that, but I think we'll largely work off another box to do the kind of demos you saw here. And then you need Skype Business to run it. Georgia Tech has one copy, and they don't want us to use that copy. So I am fighting that battle currently to try to be able to talk to Aaron over in St. Andrews over it. So those are three of the little issues we've bumped into in using it. But it's been fun. Unfortunately, it became midterm. Our students were all engaged. They're all away this summer. So I think this fall we'll really kind of get cranking on some of the things.
Thanks, John. We've got time for a question or two, if there are any. Tim?
I'm curious, you mentioned that you're using a toolkit for the ink touch.
Mm-hmm.
And I'm assuming it's because you're running that on a... I'm I'm assuming you're using a toolkit because you're running it on an external Windows 10 device. Why not use the inbox pen and touch controls that come with Windows 10?
I'm not sure we know how to do that, or we have made little reach outs. So before we got the hub, we were doing the other things. So that's actually Java processing Christopher's toolkit in order to get that. I've dropped a few emails to a couple people at Microsoft saying, what do you use? What do you do? And I didn't get good advice along those lines. So
We'll work on that.
I'm happy to get that help. A challenge as well for us in a very practical sense, for instance, if an undergraduate wants to work on it, it's like, what do they know? And then what's the quickest path to a very cool demo that we think about? Yeah.
Any other questions for John? No? All right. Next up, we've got Sebastian from Darmstadt, representing the team that is the rest of the team that's not able to join us. But we're excited about having Sebastian here and eager to see what the team's been working on and what they're able to share with us.
Okay, so hi, I'm Sebastian. I'm from the Telecooperation Lab at Technical University of Darmstadt. And yeah, we'll show you some of the work we've done in the last couple of months with the Surface Hub. But before, I just want to introduce you our group at Darmstadt. So probably if you don't know where Darmstadt is, we're from Germany. So we are right next to Frankfurt. And right in between of Cologne and Munich. Darmstadt is pretty known for our universities. We have 3 universities. I'm from the technical universities with about 30,000 students. We also have the European Space Operations Center, which, for example, controlled the Rosetta missions. And we also have 3 Fraunhofer institutes. And yeah, so this is our computer science building. We have about 3,500 computer scientist students with 300 researchers and employees and about 30 professors. And what I've highlighted here are the rooms of our telecooperation group, which is under the lead of Professor Max Mühlhäuser. Yeah, I'm actually from our HCI area, and we have 4 main research interests. So that's hybrid workspaces, which tries to combine the digital world with physical objects for like a desk. So we're using, for example, the Microsoft Pixel Sense or top projected approaches. We are doing a lot of stuff for digital fabrication, like 3D printing interactive objects, which I will show you during the demos. Then we do a lot of mobile user interfaces, not only for smartphones or tablets, but also for smart watches. And we have a great interest in body-centric interaction, so like palm-based interaction or controlling stuff with touching your ear or other parts of your body. So now let's go to the Surface Hub project. So when we first got the Surface Hub end of February, we were like, oh yeah, okay, what can we do with it? It's pretty cool for meetings. And we thought, yeah, we can attach it and people will work with it. But actually, when we look at how our colleagues worked with it, it was more like a workshop scenario. So people have their laptops, they have coffee mugs, they have everything lying around. And we thought, yeah, why not using it for to integrate the Surface Hub to the whole room, not only for presentations or visualizing stuff. So one of our first ideas is to use customized 3D printed tangibles to interact on the Surface Hub. So what I have here is, for example, a 3D printed jar. So it's the white part is just normal PLA plastic, but we also printed conductive PLR inside of it. So if you hold it and put it on the screen, you can interact with it. You can think of to manipulate. I hate this word. Sorry. To work directly on.
Manipulate.
Thank you. Directly on the Surface Hub, and like using it for stuff like dragging stuff or pushing stuff aside, interacting with it, and with the haptic feedback of a physical item. So, first example I will show you is a very basic physics-based visualization of a context application. So we have several contexts from different social networks visualized as data points. And we can now use our 3D printed objects to interact with them. And it allows us to filter those data points. And yeah, you can, of course, use it collaboratively. So here we'll show you the first demo. So, okay, maybe for the camera it's better here. So we have simple context. So, like for example, that's me. Like it's representing my Google Plus account. I can drag me around and also throw it around because it's physics-based. For example, we have Bill Gates here with his Skype account, and I can also throw them around and have some fun. But what we now want to do is to use our 3D printed tangibles directly on the screen. So I can just use it, and now I can collect the data like this. Because of the custom touch patterns, we recognize that object and can do stuff with it. Like I can catch it, you know. And now, as I mentioned before, we can also filter that data point. So if I select this, for example, I don't want to have the WhatsApp contacts. Why is it not? So I don't want to have them, so they just fall through the classes. I can also use a second class, which could be tricky now. But if I collect them, I can just pour them into the other class. For example, I don't want Skype, I don't want WhatsApp, Facebook, I don't know. And now I collect, again, other stuff, and all the data I don't want just fall through my tangible. We're working on different tools as well, not just glass jars, but yeah. Okay. Okay, so next thing is we not only want to use our idea of having customized 3D printed tangibles to interact with the device, but we also want to integrate the personal devices lying around, so like your smartphone or your tablet. And our idea for that was to have some 3D printed tokens. So in this case, I brought to you some 3D printed Stanford bunnies because they look cool. And now, often the problem occurred that one of our colleagues wanted to share some stuff on the screen, but didn't want to show his whole screen device. Yeah, so I mean, you could probably use Miracast or plug it in directly through HDMI, but sometimes you just want to share a single item like a picture or a video. You could now use USB or NFC to transmit something, but not every device has NFC, and not every, it's not always the easiest solution to use USB storage, plug it in, copy data, and put it on the screen. So what we did here with our Stanford token bunnies, we can use the touch screens of normal mobile phones, because every phone has a touch screen, and also a lot of notebooks nowadays have touch screens, to detect them as well on this device. So we can select single items, can store it on our token by putting it on the screen, and then transfer it to the Surface Hub. So here I have a second demo for you. Where is it here? Okay. So what you see here is a simple picture gallery where we have pictures uploaded. So for example, there are some pictures when we received our Surface Hub. That's our admin trying to configure it at first. And to show you how it works, I would just take a picture of the audience, if that's okay for everyone. So like this. Actually, I would love to show it via Miracast, but it was not working this morning. So you have to trust me, I took a picture of you. And now I use the sharing context of my phone, and just use one of my bunnies, put it here, and now it's virtually stored on my 3D printed token. It has no logic inside, it's just a printed object with conductive material. And once it's uploaded, I can just go to my Surface Hub and, oh, it's not working. Oh yeah, no. And now you can see the picture here. So you can also do it vice versa. So you are not restricted to just put something from your personal device to the screen. You can also use the tokens to collect pictures. So for example, I can grab this one, or I can grab this one. I can also copy this one if I don't have my token too long on it. And then I go to my app and just put it on the screen, and it's downloading the images I just collected from the screen. So I will give around the tokens later so you can play around with them. Also, what I want to mention, we have printed 2 different tokens. So they have different positioning of the single touch pattern, so we can recognize them distinguishedly. So if I would use the green one, it would be stored on this token. If I would use the yellow one, I would store the items on that token. Here we want to have them a bit smaller, but one problem occurred when we use it with the Surface Hub is that the touch points needs to be a bit more far away than on a mobile phone. Also, if we have the conductive material too close to the actual touch points, it's recognized as some hovering hand, and then we don't get a pattern, because if it's like this, you can't do anything. So we have to, that's why they are so bulky at the moment. Okay. So back to here. Yeah, and after we had the integrated personal devices and have our 3D printed objects, we also thought, okay, how can we provide personalized input? So similar like Michelle presented earlier this morning. We also did some work on this, but we did not want to have the user to wear any additional devices. So we thought about putting multiple Kinects into the room, which tracks the user. They communicate via TCP, so we can map the touch point to the correct user. And because we get sometimes different skeletons from the same person, we have to map both Kinects, and we do that by just simply color track the clothes and then map the different skeletons for one user. So that's stuff we're currently working on. So I can't show you a demo today. Also, the setup is a bit tricky at the moment. But I have prepared a small video. So what you see here is my colleague entering the scene. He can now start drawing. So it's a basic drawing whiteboard application. So he's drawing a nice face. And if he leaves the scene, the system recognizes it and hides the session. So when he re-enters the scene, the session gets restored, and he can continue drawing. And now my other colleague will enter the scene, and he is also tracked by our system and is recognized as the purple user and can start drawing his own stick figure. And soon, now you can see he can also draw on his part because his touch point is still recognized as this user. So, yeah. Now more a bit of our future outlook, because we haven't done anything so far for that, is personalized output. So if we use some augmented reality glasses, such as the HoloLens, for example, we want to have additional information augmented for just one person, because we think that the augmented content will enhance our digital content. For example, right now, if I'm doing the presentation here, and I don't have my laptop now, so I don't have my annotations, I could just use some augmented reality glasses to see my annotations. Or if we use the sharing application, I could see a gallery with maybe some private pictures you should not see, and I can select them and then only show the stuff I want to show. So yeah, here's basically an overview again. So we have shared content like it is now. We can overlay private contents directly to the Surface Hub or in midair. We can have some labels. And also, as I mentioned before, we have done some work on body-centric interaction. So we have some other augmented reality glasses where we can project stuff on the hand, and also did some palm-based interaction, which we also want to integrate here. Yeah, so that's basically all, just a quick summary. So we have those customized 3D printed tangibles to interact directly on the Surface Hub. We have an approach to integrate personal devices and enable easy data sharing. We are working on personalized input by tracking the user with Kinect, and our future outlook is to also work on the personal output side. So, thank you.
Thank you, Sebastian. Any questions from the group? Come on, that was some cool stuff he showed us. All right, Dave, hold on, here's a mic.
In your setup and your demo, to using several Kinects to identify who's touching and looking at skeletons, how challenging is that in terms of dealing with kind of occlusion issues and also the full screen coverage?
Exactly, that's why we can use multiple Kinects which communicate with each other. Because if we just have a Kinect at the back, you mostly just occlude everything you want to see. For example, we have some different work which is called Permoline, which is a tabletop where we can also, because it's a custom-made tabletop with a 3D television, and we also want to recognize who is touching. And there we have a top-mounted Kinect. So for that, it's working, but in this, we have to use the Kinect, and they can be like here, and some is like there. So if I'm standing here, it's still tracking me, and I'm not occluding the contents.
And how reliable is it in your experience?
Yeah, we're working on it. I mean, you saw the demo, the video. Yeah, it's a relatively new approach from our side, so we're still working on it. But we think it's pretty cool at the moment, and yeah, of course, potential to improve it.
Very interesting. Thank you.
Thank you.
I'm just wondering if you've played with using a RGB camera and looking at facial recognition, correlating the position, at least in 2D, of the face with the touches on the screen to identify people based on face rather than skeleton.
No, we didn't done anything like that before. But it's a cool idea, yeah. But at the moment, it's just the Kinect skeleton tracking and mapping it to the touch points we get from the Surface Hub, and then we map both to locate which user's touch point it is. Thank you.
Anyone else? All right. Thank you, Sebastian.
Thank you, too.
Next up, we have the first of the two teams from Brown. So Andy, I'll invite you to come up and introduce the crew.
I want to start off by thanking Roy and Stephen and other people who helped organize the workshop. I'm very grateful to Microsoft for running Faculty Summit and these associated workshops, and certainly for the gift of the hubs. They're terrific, and we've really enjoyed using them. We come from several decades of work already on tablet PCs, where we emphasized pen, of course, because that came before touch became so widespread. So I'm not going to talk about that older work. We did MathPad, Music Notepad, ChemPad. You can see the trend there. And it's all based on sketch recognition. We're doing rather less with sketch recognition today, except in one project that I'm not going to be showing, which deals with 2D, very precise geometric drawing. And the work I'm going to show via my PhD students here is more concerned with handling data and using pen and touch for interacting with that data. So first up is Emmanuel's Gragen, who is being shared between my group and the database group. You'll notice that Tim Kraska was on the program, but unfortunately he couldn't be here today. He sends his regrets. Tim is co-supervisor with me of Emmanuel's PhD work, and it lies in the intersection of pen and touch user interface technology and large-scale database visualization. And I'll let Emmanuel demonstrate his work. By the way, just feel free at any time to say, whoa, what did he just do? We have, fortunately, enough time.
Thanks a lot,
for
Andy.
that luxury.
So yeah, as Andy mentioned, this is work that we do with the database group at Brown University. And more recently, we're also working a little bit with some theory people because there's a couple of problems that interested those guys. So what I'm going to show you is a system called Wisdom. And it's a data exploration, data analysis tool. And has sort of two main focuses. One is the interaction that I'm going to show you, and the other one, the part that Tim's group are doing, is sort of the back end, the database engine that supports what we're showing here. So one of the goals with this is to support data sets from small sizes, a couple of thousand records, up to really large data sets, in theory, almost as big as you want. And that's sort of the research challenge in the database group. And the way we do this is by using progressive computation and progressive visualizations. So the idea there is that you stream samples randomly from the database and sort of start visualizing or computing stuff on top of these samples through different batches or chunks of data at a time. So here what I did is I loaded in a couple of data sets. So I'm going to show you a couple of features on different data sets. Here on the left-hand side, you have a little menu. A stands for attributes, V for visualizations, and T for tasks. We really tried hard to make this AVD, but we couldn't figure out how to change the T to a D there. Anyhow, what you can do in here, first I'm going to load, let me load the right data set. So the first data set I'm going to show you is a data set that contains information about patients from Boston area hospitals. They're all ICU patients, and these hospitals log all sorts of data about the patients that go through their intensive care units. So you have things like ICD-9 codes, those are disease codes. You have things like demographic information, physical information, and then a whole bunch of different blood testing results, for example. So you can imagine you're a person who works at the hospital, and you kind of want to figure out what kind of people come through your hospital. So you look at this data set, and you might want to look at the different ages of people that come in. So you can drag out age here, and you see the progressive computation going on. This is a fairly small data set, so it's pretty fast. But you get a histogram of the ages of people. One of the things in this system that you can do is you can use visualizations to filter other visualizations. So what we can do in here, we see that the data ranges from -20 to over 200. So clearly there must be some data entry errors there. So let's try to filter this down to a range that makes more sense. So let's say people from 20 to 100. So once I select these data points here, then you see that the second visualization here, it's filtered down to whatever you selected there. So you can do this to sort of interactively create these coordinated visualizations or to do filtering operations. So let's say we look at these patients here from 20 to 100 years old, and then we're interested in people that have a blood disease. So we drag that out and see that maybe a third of the patients have a blood disease. So we can select blood disease here. And then we want to figure out what kind of age patients, what kind of age ranges have these diseases. So I can just bring this close to here, and then we'll sort of overlay in purple the people that have a blood disease on top of this visualization here. And let's say you want to look at heart failures as well. So you can drag this over here, select, bring this close again, and then this will overlay too. And in black, you see sort of the people that have both types of diseases. So what you see here is that between 30 and 40, people have mostly blood disease and not a lot of heart failures. But once you get older, you kind of tend to have either one or both more often. So this is kind of the basic interaction model that you can have here. So you can create links between visualizations to filter, or have these sort of brushes that you can bring in and out to see data in context of some other visualization. So what we did when we first got this data set is we played around a little bit. So, and one of the examples I like to show is when we were interested in patients with a fever. So let me drag out temperature here. And what we wanted to figure out if there's anything that correlates with fever, particularly if people have a higher heart rate when they have a fever. So if you drag out the temperature attribute here, you see that there's kind of a whole range of values again here. It goes from 0 to over 100. And when we first got this, we were a little bit confused why these values are all over the place. But then once you start drilling down here a little bit, you see that these values over here were recorded in Fahrenheit. But then if you look at some other values over here, you see there's a bunch of values in the 30 to 40. You see that these values are recorded in Celsius. So there's hospitals that record in Celsius and hospitals that record in Fahrenheit. So if you want to talk about patients that have a fever, you kind of have to incorporate both of these ranges, right? So what we can do over here is we create another visualization and then select patients with a fever in this range. So let's say over 37 degrees Celsius and here over 101, for example. Link these back up here and then order them together. So now these are all the patients in our data set that have a fever. And if you go back to our initial question is, do these people have higher heart rates usually than people without a fever? We drag out the heart rate here and can link this up, create a copy over here, link it up again, and then with this gesture just crossing out the line, you kind of invert. So now this is everybody except the people we just selected with this whole query graph over here. So now if you look at these, you kind of see that there's actually a little bit of a difference. But if you want to get more into like statistical analyses, you can drag these both close together, and it will just sort of generate a standard t-test and show you that, yeah, this p-value is pretty small. There's actually a pretty big effect. So these two distributions are fairly dissimilar. So yeah, so this is one example with this mimic data set, the patient's data set. Another one that I want to bring up is similar to what Stephen just showed with election data, just to kind of show you that we can have different visualizations, not just these simple histograms. Oops, not that one. Drag out a county visualization here, and this might take a while to load. But yeah, same idea. You have election results. So, for example, we might be interested in people with in counties that have a high percentage of people with a bachelor's degree. So we can select these people here, drag it in here again to get this brushing effect. And again, as you've seen before, we can combine this with counties that have a high range of people over 65, for example. And again, same idea, you could just use these tools to sort of play around with the data and figure out if there's any interesting insight that you might see in here. The next example that I want to show you is one of these standard machine learning data sets. And this one's actually a little bit bigger. So the ones we saw are fairly small data sets. This has, I think, 1 million or so items in it. And this is just one of these example data sets. So you drag out here, and here you kind of see that the progression is actually going on, and these histograms slightly change over time. The more data you stream in, the more accurate they get. So here we have a histogram of miles per gallon, and we can drag out country of origin from this data set talks about cars, so we can select, for example, cars that come from this country 1, link it up here again, and then we can just kind of play around, see what kind of distribution of miles per gallon country 1 produces, country 3, and we see that this is fairly dissimilar. So one of the things you might want to do is you might want to ask yourself, can we build a classifier that tells us if a car comes from country 1 based on a set of different features? So what you can do in here is, in this T menu down here, tasks, you can drag out different types of machine learning algorithms. So here we're doing a stochastic gradient descent. And what you can do is you can say, I want to use MPG as my feature, and then use this origin, country 1. This is what we want to predict. We want to predict if a car comes from country 1 or from any other country. So this is a binary classifier, basically. So I can bring this again close to here. And then you see that this model is sort of trained again progressively in the background. And here you just kind of see how this, the test accuracy of this classifier sort of evolves over time the more data you stream in. So you see here we have 74.8% accuracy. And then there's a bunch of different visualizations. So you can tap on here to get more details, sort of the standard confusion matrix and F1 scores and all that. And then you can sort of inspect in more detail where are the errors made in terms of the features you have. So here you see, if you go back to the confusion matrix, you see in different color codes, false positive, false negative, and all these kind of things. So you can kind of drill down where your model actually makes its mistakes. And you can also test. So let's say we want to see if we have a car that has 10 miles per gallon, we can write this in here, and then we'll sort of test your input against the model that you're building in the background. And if this comes back, I don't know, it might be a little bit slow because I'm running it off my little tablet there. But the idea is you can sort of quickly input test data to see where your ongoing model that's being computed classifies these things. Just to kind of show you that this actually scales pretty well to even larger data sets, I just downloaded this data set from a recent Nature paper. It's about particle physics. Don't ask me what these attributes mean. I have no idea. But this is fairly large. I think this is around 20 gigabytes uncompressed on my machine. And it's about 15 or so million entries. So what you can do here is the same idea. You just drag out any of these attributes. And you fairly quickly, if it didn't crash, should get a histogram of this data set. Maybe I killed it. Yeah. Yeah, anyhow, just wanted to show you that it actually would scale in theory to larger data sets. And this is part of the sort of the research that Tim's group is doing, how we can get fast responses even on these large data sets, and how to randomly get samples from a database. Yeah, that's all I got.
Questions for Emmanuel?
I really like the fluidity with which you were doing that. And one question as I'm watching that comes to mind, since, of course, I'm not familiar with those data sets, is there's a story that you're telling, basically, and a history. And if you, or certainly if I were to go back and look at that after the fact, even if I saw the things you were pushing off screen, I might not remember what was done when, for example. Do you have any sense of history, being able to unroll the history, for example?
Yeah, no, we're actually not storing any of that, but you could imagine doing something like that, yeah. You can annotate a little bit, as you've seen, with just basic handwriting, so that helps sometimes a little bit to get back and look at what you did.
But not just for you to be able to know, but for the system to be able to know.
For the system to be able to know?
About the history of what you did so you could unroll it, for example.
Yeah.
Or you put a couple of things together, for example, in certain patterns, and maybe think of those as being templates that you could then use to replace some of the input parameters in the same pattern that you had just done that, to be able to very quickly, for example, have it iterate over a whole bunch of sets of different parameters.
Yeah, that's an interesting idea. No, we're not doing anything of that. What we do is, for the back end, we're taking into account what the user did in the past to sort of try to predict what should we load next, just to be faster with our responses.
Right.
These kind of things, but yeah.
We could have a history capture mechanism. That would be a complete add-on, but that's a good idea.
Which also raises issues of redo and undo and macroization and other stuff that dates back to work David Kurlander did with me, but is frightening to realize a quarter of a century ago. Wow.
Good ideas keep coming around. Anybody else? I want to thank Stephen as a vital part of Emmanuel's education and work experience. Emmanuel interned twice with Stephen here at MSR, and Stephen is now also serving on Emmanuel's thesis committee. So there's been great influence from Stephen's thinking and his style and aesthetics, and we're very happy with that. The next project is kind of an omnibus project, and it reprises many ideas from various other work groups, including Steve Feiner and Steve Drucker when they worked with me many years ago in the graphics group on hypermedia systems. This is yet another hypermedia system. At least that's one view of it. Essentially, we're working in the same space as the TAMU folks. We're interested in information gathering, information organizing, ideation, and then ultimately presentation. And we have a somewhat different spin on it, but you'll see many features, many ideas in common. I want to mention that, again, we love the whiteboard. It's a great piece of hardware, and we're keenly awaiting the ability to do simultaneous pen and touch. You won't be seeing that in today's demos because we haven't had it available to us, but we'll certainly make aggressive use of it once we get it. So I'm going to do a little bit of context setting, and then Philip will show you the individual features. What we have is the typical ZUI large unbounded workspace. In there, we can do a variety of manipulations that he'll show you. And what we're really after is to support small work groups as well as individuals in their ideation, in their information gathering, organizing, and presenting. So we kind of think of it as an IDE for idea development. It is a spatial hypermedia system. I also think of it as a smart desktop replacement in that, as we all have, I'm sure, used our file folder hierarchy and our emails as email boxes as organizing principles. It works to a certain degree, but unfortunately there's silos. You can't have any connective tissues between them. At most you can duplicate a file, and that doesn't make for very good organization. So what's really important to us is to be able to represent relationships, and you'll see that there are several ways of doing it. It's a spatial hypermedia system, but it also has explicit links. And Philip will talk to you about that. We're trying to deal with that stovepipe problem. Collaboration is built in. We have folks back at Brown on their tablets in our hub back there who are sharing this exact same workspace. And we don't have fine-grained locking controls. Steve mentioned that problem in an earlier talk. That's still a serious research problem, and we have a very crude approximation to that. Everybody can work simultaneously, and by the end of the summer, we hope to have some ACLs and other controls over who can do what with what kind of grain, what kind of granularity. So this project is pushing in some specific areas that we're very interested in doing research in, but it's also a large system integration project. I'll briefly mention some of the vectors along which we're working. Relationship and annotation modeling a la hypermedia. It is a ZUI. We are trying to use as many ZUI and NUI techniques as possible. We do want to emphasize collaboration. This blue polygon kind of indicates how far we feel we've come along these axes, and you can see we're still in a very early stage of development. We are interested in exactly the problem that Steve mentioned, which I think of as history capturing. We have a very crude snapshot ability at this point. We don't even have undo, redo yet, which is fundamental to any interactive system. There's obviously a thrust in visualization of various kinds. Search is hugely important, and Philip will demonstrate various takes on search and automatic algorithmic sense-making, topic modeling in particular. Again, very embryonic so far, but I think you can see the beginnings of an idea. It was very important to us that for once we not build a closed hypermedia system as all the other ones have been to a first approximation, and that we particularly interoperate with the Office suite because that's what we use in our daily work. We use PowerPoint, Word, Excel, and so on. So you'll see some small degree of interoperation in today's system already. And at the end, obviously, at some point, you have to be able to present. We have the very simplest kind of presentation at this point. And can we advance here, or can I just swipe here?
You can just swipe here.
Yeah, go ahead. So kind of a Prezi-style presentation, which we also saw in your presentation. Very primitive, but it serves unto the purpose. These colored areas that you saw when I zoomed out are what you can think of as geographic neighborhoods where you sort your piles of documents. We have PDFs and JPEGs and videos and audio files, so it is a multimedia system from the get-go. And we find that these spatial organization techniques are very useful in addition to the linking. And you can't just have linking as your only relationship building mechanism because very quickly you get spaghetti and you get visual clutter. So we want to use a combination of ingredients. All right, Philip, all yours.
All right. Is it right? Okay, perfect. All right, so I'm just going to close this real quick. And startup news is again. So, yeah, as Andy mentioned, it's kind of a hyper media system that we're developing. It's actually very much, or kind of similar to what we saw this morning from ATM. And you'll see what I mean by that in a minute. So I'm just going to log in real quick. All right, so we start off with a empty workspace, really just a whiteboard where I can use ink. Our focus is though more on creating structures with content on the whiteboard. So our goal was to support as many digital media types as possible, have people be able to import that onto the whiteboard and then create structures. Kind of like support tasks that you would do in OneNote, for example, but in a much more playful way. So those 3 buttons that you see on the top left is our little menu. So you can move it around. If you stand on this side, you can just drag it back there or pop it up. In the middle button right here brings up a library. And the library is basically just a view on a list of data that is stored on an Azure service. So everything every content that people bring onto the whiteboard will be uploaded to that Azure service so people can access their content from wherever they want. For this demo, I'm just going to walk you through a little use case. So you probably all know Andy Van Dam. He's the teacher of the CS15 course at Brown. So imagine you're a freshman or sophomore again, and Andy tells you that you have to prepare for the next midterm, and he tells you that he uploaded all of his content to Newsys. So first thing we do is we're just going to search the library. We're just going to search our cloud for the content that you have to study. So I'm going to type in CS15 right here. Then I can sort those columns, just a typical table by, I can sort a table by columns. So the second entry says CS15 midterm. If I want to bring in the content to the whiteboard and actually interact with it, I can just drag it out from the library. Do this, and a little text note shows up. Then this text note says, I have to study linked lists and trees. So I'm going to look for linked lists. It's already there. Lecture 16. Going to bring it in. This is a PDF, by the way. And I'm going to bring in trees. So you see that PDFs are rendered inside of Newsys. So you, again, we try to support as many content types as possible, such as videos and audio files, etc. And now, the big advantage of using Newsys over other applications like this is that we want to support as many viewers as possible. So any content that you can bring in and create structures with are actually displayed within Newsys. So you can actually see what you're linking to and what you're structuring. So for example, I'm just going to go through this lecture 16 real quick. I can resize it. I can resize each element individually if I want. I can pan and zoom as you saw before. If I tap the element once, I get a set of menus. And it allows me to do things with that particular PDF. So I can flip through the pages like this. And I'll say I have this one slide, and I want to look at another slide in the same slide deck simultaneously. What I can do is I can simply use the drag and drop gesture and create a duplicate of this slide right here, like so. And then just go through a different page. So I can basically create new slide decks, if you will, because in many cases, not all of the slides are important in the slide deck, and you just want to create new collections of those kind of things. And that's exactly what we're going to do here. So I have 2 slide decks open right now, and now I want to create a new collection of these. I want to group those 2 items. I can simply use the drag and drop gesture to do that, drag and drop them on top of each other. And by default, I hope you guys see it. By default, I just get a list view. And similar to Windows Explorer, I can just choose a different view. And because we are very much focused on free-form interaction, you can convert this collection right here also to a free-form collection. Just going to do this real quick. And I can move them around. Again, and basically do the same interaction as with the big collection that's shown full screen. So this is how you import content, how you create very simple structures. But what if you want to author content? What if you want to add annotations and notes to your study material, for example, in this case? So I'm just going to bring up the menu right here. So say I want to take a few notes on this. Bring up the menu on the left and then drag out a new empty text node. I can activate it again, and then you'll see a bunch of options here. I can use the on-screen keyboard to enter text. But naturally, that's not great, especially when I use this on a Surface Hub, because I can't really type a lot of text with an on-screen keyboard. So we implemented this speech-to-text functionality, which I can trigger by pushing this button right here. This gives me just make this a little bigger. This gives me, it's empty space. Let's ignore this real quick. And now I can press this button right here to record my speech and convert it to text. Hi, my name is Philip, and I really like the food here. Stop. And there we go. That's one type of recording that we support on Hub. It just makes it easy to record longer texts. We also support audio recording, so I can drag out a recording node, toggle between audio and video. I'm just going to create an audio recording real quick. Hello. Let's see if that works. Hello. All right, that worked. And the same for videos. There we go. All right, not a great video, but you get it the point. So what you can use is also, why this is really useful is that, especially in a collaborative setting, there might be cases where you want to leave a note to some other person who's studying the same material, or you want to explain your peer how an algorithm works, etc. And you can do this all by creating those recordings. You can lay them out or even like put them spatially close to whatever they relate to. And when it comes to relationships between those different documents, we also support a different type of relationship, which is a visual link. So if I want to emphasize the relationship between the note right here and this lecture right here, I can tap this box again and then drag out a link and drop it onto the PDF. So this would create a visual link, just emphasizing the relationship or the fact that they actually do have a relationship to each other. And then I could use this text box to annotate the link in some ways. I'm just going to do this for all of those types really quick. There we go. All right. So what I just did is I linked two documents to each other. But as you all know, when you look at documents, especially multi-page documents, then most of the time you're only interested in one piece of content, maybe an image or figure or a paragraph in an entire slide deck of 80 slides. And that's why we support regions within documents. So regions allow you basically to create a spatial region in any document that you can link to, that you can add metadata to, so that people can easily find it again through search, etc. I'm just going to show you how to do this real quick. You can tap this guy and then maybe go to a page where we can see a little graph. Then I can double tap this node, and double tapping brings up a close-up of this content right here, which is just a fixed view. So imagine if you were to take notes on content on the workspace, you could bring up a text note right here, keep adding notes while you browse through the workspace. Now to create regions, I can switch to the regions tabs here, then hit the plus button right here, and that would create a rectangular region. I'm just going to stand here real quick so you see it. This is the node on the workspace. This is the close-up. I'm just going to drag that guy on top of the graph or figure, and then let it go. I can rename it if I wanted to. And now, if I want to link to it, I can simply drag out a link from this guy to this guy. And that will create a link relationship that you can, again, inspect in the detail view later on. Now, to show you that this actually worked, oops, just throw away the library. Here we go. I'm going to open the lecture 18 here in the library, and now I see that the region was added. So all of the regions that belong to a particular document will be listed here, and if I double tap here, I jump straight to that region again. All right. I told you that we support many different document types, and one of the more challenging document types for many applications are Office documents, because they used to be proprietary, they opened up, but they're still kind of like hard to render within third-party applications. But we found a good way to do that. And Trent is connected right now. Trent, can you hear me? Okay, I'll crank it up. All right. So this is Trent right here. He's in our lab right now on the same workspace. And I'm going to ask him, I'm going to import a Word document right now and then ask him to change it within Word. So I'm just going to search for the Word document real quick. It's called linked list. Drag it out. And now if you look at it, this is an actual Word document. Just the view, though, you cannot change it within NewSys, but you can view it exactly as is. Trent, can you quickly change it?
Yeah, I'll change the title.
Yeah, just change the title. All right, here we go. So it updates automatically. Every time you save your changes within Word or any other Office applications, it would re-upload the document to our cloud and then download again to whatever client is connected. Trent, just to make sure, to prove that I wasn't lying about the collaboration, can you quickly move a few things? Trent?
What did you say, Phil?
Oh, can you move a few things on the workspace? Okay. All right. So again, and all the collaboration is real time. So you see live text updates, live resize updates, live, pretty much any type of motion or changes that are applied to the workspace. Thanks, Trent.
Yep.
All right. So the second last thing I want to show you is that when we developed this application, we always had visual analytics in mind. So we wanted to be more data-centric than other applications. If you're familiar with OneNote, if you add content to OneNote, it's kind of hard to find. You have to tag them manually. They're not listed anywhere. If you want to reuse elements, it's really you actually have to find the elements in a workbook, then in a section, in a subsection, the copy or cut and paste and so forth. And we kind of wanted to improve that workflow a little bit. That's why we decided to allow users to add metadata to any type of documents that are within NewSys. So I imported a paper right here, Mark Bernstein's spatial hypertext. If I bring up the detail view of this document, you'll see that there's a metadata tab, so I can switch to that tab. And there are a few pre-assigned things when you import a document, so like timestamp, the creator, and so forth. There's also system-generated metadata. So for example, you can see there's a thing called system-suggested names, and we have an algorithm running that extracts names from PDFs, first converts them to text, then extracts names from the text, and so forth. That's just metadata that's automatically added. You can add as many key value pairs as you want. You can also create tags. And the cool thing about tags is that this feature is already in OneNote, but nobody really uses it because you have to do it manually, and you don't really know if you're going to reuse this piece of content anyway, so it might not be worth spending or making the effort of tagging things. So at the bottom, I don't think you can see it. Right here, there's a list of suggested tags. So we use topic modeling to figure out what topics are what topics this document is about, and then just display them in a list. And then I can just go through that list and assign those tags. So for example, there's hypertext. Here we go, and maybe structure and so forth. And those tags are shown here at the bottom of each document. Now what we use is not trivial, but it's kind of like a simple algorithm that's publicly available. What we plan to do in the future is to leverage APIs, such as the Microsoft Cognitive Services API, that we can leverage to just display more information more accurately. Because we're not experts in that field, we're experts in other fields, and that's why we just want to leverage as much knowledge as possible. Yeah, and now, the good part about the whole metadata thing is that it allows us to perform visual analytics on a workspace, on things that people work on a daily basis. And just going to show that with a very simple query. If I open up that menu again, you see there's on the very right, there's a thing called Tools. And if I drag out Tools, it asks me, or it allows me to filter the library by some attribute. So for example, if I want to filter the entire library that's right here by type, I can just select type. And then I get all the different types that are currently in our library. I can switch to a pie chart, so it gives me an idea of what the ratio of number of documents are in the library. And then I can start dragging things out of that pie chart. For example, if I'm interested in all the names of all the images that are currently uploaded, I can drag out the image slice, hit title, and I'll see all the images. If I want to switch back to PDFs, I'll see PDFs. And this is very much similar to Emmanuel's work, where he also used interactive charts. It's just a very easy way to filter or drill down in a big amount of information. Because you can imagine that when 10 people work on this system collaboratively and they all share their documents, the library will grow like crazy, really. It's going to be really hard to find stuff just by using text. So things like that will definitely simplify that process. And then, yeah, so the last part I'm going to show you is just a little more complex query. Leveraging the metadata that's automatically assigned. So I'm going to drag out the tools again. And now I'm interested in finding documents that contain a particular name. So for example, I want to find all Bill Buxton documents or things that contain the word Bill Buxton. So I'm going to go to all metadata, then select system just suggested names. And again, this is not hooked up to any database or anything. It's really extracted from plain text. Then, oops, that was too early. Here we go. So I'm going to enter Buxton. There we go. And there's a few entries you can see here. Bill Buxton is spelled differently in different documents. Just going to drag out the first one. All right. Hit title. So this is the one document that contains b.buxton, right? If I want to select all of Bill Buxton, however his name was spelled, I can just select all of them, and then this list right here would update. All right. So I got this. And now, to make it a little more complicated, I want to find all the papers that have the name Bill Buxton in it and Michel Bahut. So I'm going to drag another filter out, all metadata, search for Bahut. Oh. There we go. Then select all of them, and then drag them onto the list I just generated before. And what it does is it just displays the union of both sets, and I can simply switch that by tapping on here. So I'll find two papers that have Bahut and Buxton in it, and if I want to display them on the workspace, I can just drag out a stack So they'll be stacked on top of each other, or I could just put them, drag out the collection, and they'll be put in a collection that you saw at the beginning of the presentation. Yeah, I hope that gave you kind of a...
Can you do the CTED video, please?
The CTED video? Yeah. It's not in here, but I can launch it from my website.
While Philip is manipulating, I should mention that there's a team of 8 undergraduates back at Brown this summer working on this system, and they also, most of them work during the academic year. So it's a nice graduate student, undergraduate student mixture like many of you have in your own labs.
Yeah, so what you saw was basically the main part of our project. This is the core, basically, where things documents get structured. We branched off a little bit branch out a little bit and try to figure out how can we improve the importing phase of documents. So how can we simplify the process of bringing a document or any type of information to our workspace? And we developed a little browser plugin. I'm just going to play the video because it explains it pretty well, I feel like.
Selecting and extracting content such as text, images, or tables from websites is a common task for information workers. However, browsers only offer crude support for this task and heavily rely on the underlying HTML structure. This introduces a lot of problems. Popular websites such as Wikipedia make heavy usage of floating images, for example. This makes it hard to use the standard browser selection mechanism to just select the text we're interested in on this site. Similarly, selecting just the cells from 1950 to 2000 in this table can't be achieved easily. Browser selection completely fails if we want to select images from this image search, and we have to revert to alternative strategies such as saving the images. CTED introduces novel gesture-based selection techniques that allow users to accurately and robustly extract parts of websites without being constrained by the underlying HTML structure. Furthermore, CTED allows users to tag extracted content, and it preserves semantics and context of user selections. All selected content is stored in a local repository and can be filtered and retrieved based on user-specified tags, the actual textual content, or contextual information such as URLs.
Yeah, so this is kind of a standalone project. We developed it with Newsys in mind, though. So all the selections that were just made in that video could just be easily exported by pressing a button to our workspace. That was kind of the original goal of this browser plugin. Yeah, thank you.
Any questions?
Here, Dave.
You showed gathering and organizing. What do you have in Newsys for presentation?
Right now, just the one that you saw briefly at the beginning. So precisely like camera movement from one node to the other. That's pretty much it right now. Yep.
So it's part of the spider diagram that we've worked on least so far. Okay. We want to branch out into nonlinear narratives. And that's a difficult space, and maybe next fall, I'll have a small group of people start on that.
Are you familiar at all with Perceptive Pixel's storyboard?
Yes.
Thing? Okay.
We've seen it. Jeff has showed it to us.
Multiple times.
We've talked about it. Right. There are good ideas in there for sure.
This new CTED stuff, which I hadn't seen before, have you published that already, and are you making it available?
We published a, what was it called, late-breaking work paper at Kai this year.
And is it in Chrome? Is it in?
It's Chrome. It's Chrome only right now.
It's a plugin, or?
We were actually going to do it for Edge, but then at that time the API wasn't there, or it was experimental, and so we decided to do it in Chrome.
I think it's really useful for enabling all these things.
Absolutely, yeah.
Yeah. We would love to have good APIs for a whole bunch of stuff, But unfortunately, the APIs are underdeveloped and they don't give you everything you want. So it'd be great to work with people in Office, for example, to get deeper access to Word and PowerPoint and so on. And maybe Roy can make that happen.
One of the wonderful and at the same time awful things about hypertext, especially things like worldwide hypertext, is that they change even as you're doing stuff. So I'm wondering if you had gone through that collection of pictures, for example, and very carefully selected this one and that one and these ones over here, and then you wanted to come back the next day, right? And see what things had changed and not have to do it all over again. Have you looked at, thought about, had your knees quaking about how you do that?
Yeah, we definitely have. So one of the things that we were going to implement is just history tracking, basically, and then allowing users to replay the entire evolution of a workspace.
Right.
Yeah, that would be one of the goals, so that you can actually see how your ideas developed on the whiteboard.
It's a somewhat different question because you had made a selection from that set of pictures. You got a response to a query, but if you come back the next day and reissue the query, you might not get the same pictures. Some might disappear, some might be added. And had you thought about ways in which you could make it easier for someone who wanted to reuse what they had done previously and yet didn't want to stick with the results that they had gotten before?
Right. Currently, there's ways to duplicate the content manually. So you can always create a duplicate of the current state of a doc or any type of document. So you could do the same thing for entire collections. So there are ways to store things like that if you wanted to go back to that at a later point, make sure that they didn't change. But you actually have to do it manually. There's no UI that supports you in doing this, really.
I'm really thinking of taking advantage of the new things and not just having to, duplicate and store and cache what you've done before.
Yeah, absolutely. Okay. Yeah, but there's nothing like that right now. Yeah.
It's an intractable problem.
It's a difficult problem, but one you might often have and want to exercise.
Yeah, well, for example, you'd love to be able to take something out of a Word document and have it linked to an annotation on the Nooses workspace. But then what happens if the anchor gets deleted as part of the paragraph? You know that problem.
Oh, yeah.
There's nothing you can do about it, basically. There are kludges that give you approximations, such as when you delete the paragraph, you can maintain some labeling of the fact that there was an anchor there, but you can't have the original information still because it's been deleted.
Although in that case, you could actually do a diff from what you had before and what you were seeing now and highlight the things that were new and the things that were deleted and be able to take advantage of the work you'd done previously. Thank you.
Any other questions? Okay.
Thanks to Microsoft for supporting the work, by the way.
Thanks to the Brown team and all the other teams also. So we have earned ourselves back 25 minutes, and here's how we're going to spend it. Lunch is actually ready for us, but before we do that, I want to take an opportunity to try and spark just a little bit more networking that might happen as a result of this conference or this workshop. So what I'd like to do is have sort of a speed round of introductions, particularly for those people who haven't had the opportunity yet to come up to the front of the room, or those small people in the back of the room that want to make themselves heard. So why don't we just start on this side, say your name, say where you work or where you work, and a sentence or two about what you do, and let's just keep in mind that you are the only thing standing between yourselves and lunch, so keep it brief.
Hi, my name is William Emery. I am a principal mechanical engineer. I work within the Surface Hub division, and my primary responsibility is managing the mechanical engineers that built the displays that you guys have and love at your facility.
I'm Charlie Case. I am manager of the electrical engineering on the Surface Hubs. I report to Dave Slobodin, and pleased to be here.
Hi, I'm Jason Wilson, a materials engineer from Surface Hub.
I'm part of the advanced development team looking at next generation products and materials.
Hi, I'm Bob Williams, the hardware product architect for Surface Hub. I helped specify all the features of the products we have now and future ones going forward.
Oh, okay. Well, my name is Scarlett Twiderski-Groscher. I'm actually Roy's colleague working in Microsoft Research Outreach, but from the Cambridge lab in England.
So hi, I'm Vijay Natarajan. I'm from Indian Institute of Science in Bangalore. My research interests are scientific visualization and geometric algorithms. So I look forward to this workshop and see what kind of visualizations we can do on the hub.
I'm Carlos Scheidegger. I'm second year at assistant professor at University of Arizona. I do work in the intersection of big data and database systems and sort of designing the backends to support interaction quickly. So.
I'm Stan Birchfield. I do computer vision for Surface Hub.
Hello, my name is Duncan Park, and I'm a PhD student at the University of Maryland, and I'm working with Stephen during this summer to develop some kind of visualization grammar for unit visualization like a sentence.
I'm Jonathan Gruden. I'm an MSR. I work mostly on digital ink on tablets and education, but I get asked a lot of questions by educators about what's happening with Surface Hub, so I'm here to find out more about what I can tell them.
All right, Tracy, here's your chance.
Hi, I'm Tracy Hammond. This is Ziggy. You probably heard him speak already. I am a professor at Texas A&M University Computer Science and Engineering, as well as director of the Sketch Recognition Lab. So we do a lot of sketch recognition, activity recognition, haptics, HCI. We have one of these Surface Hubs. We have 4 working applications on it. One is being used by 500 Girl Scouts. Another one is being used in neuroscience for stroke patients with a doctor at the HSC. Another one is not being used by anybody yet, but it's in the progress, teaches Asian languages. And then the last one is being used to teach drawing at Georgia Tech, although we don't have a big device there yet. So we'd hope to get it so that the instructor can use the big device while the students use their Surface to practice drawing with pens. So, yeah.
Hi, I'm Lucy Van Clunen, undergrad at Brown, and I've worked with Andy in the past, including on some of the early designs for NUSA, so it's really exciting to see. And I'm interning here at Microsoft this summer.
Hi, I'm Brett Brewer. I lead the planning and strategy teams for Office. Part of those strategies is what does Office mean on large screens?
John, I think we've already had the good fortune of your introduction, so we'll head over to Bong Shin.
Hi, I'm Bong-Shin Lee. I'm a researcher at Microsoft Research. My main research is information visualization and human-computer interaction. And I've been trying to leverage natural user interfaces like pen and touch for information visualization, not only for exploration, but also for presentation and storytelling as well.
Hi, my name is Sheila Carpendale. I also primarily do information visualization, but have actually for quite a long time been looking at Infovis on walls and tables and collaborative aspects of that and interaction aspects.
Hello, my name is Sergey Berezin. I am from Moscow State University, and I'm working on software tools for domain scientists, and these tools includes lots of interactive visualizations.
My name is Steve Feiner. I'm a faculty member at Columbia University. I'm interested in how we can use wonderful devices like this, not only standalone, as we've seen so far, but also in context of a whole menagerie of other kinds of displays and interaction devices, especially including, but not limited to, see-through head-worn displays.
I'm Tim Bakke. I'm on the Microsoft Devices marketing team. Very interested in understanding sort of what is happening in not only large scale pen and touch displays, but also how devices work together, principally around inking and touch, but just fascinated by all the innovation that you guys are working on.
Hey everyone, Esther Hawk from Microsoft as well, on the same team as Tim, a first-party devices marketing, focused on Surface Hub now. So I'm pretty brand new, so I'm really learning a lot from all of these presentations. And formerly I was on the band and health product marketing team, and before that I was a product planner for Xbox. So seeing Connect plus band plus Hub is very exciting.
Hello, I'm Arcadia Reddick. I'm currently teaching at the University of Washington, Bothell. Computer science. I teach computer graphics and software engineering. Before that, my background was civil engineering, and I was doing a lot of augmented reality and VR. I also did some work at Microsoft, Visual Search. So my current work is HoloLens, augmented reality application and construction.
Dave?
Hi everyone, David Brown. I work at Microsoft Research. I have a focus on natural user interaction and currently very interested in data visualization, particularly with a spin on 3D.
I was going to save this for the end, but I know a lot of people have to leave around 1:30 or so. I think we all owe Roy a ton. He's put a ton of effort into this, and I really want to thank him. And we'll do that at the end too. But please express he's been really fantastic.
Hi, I'm Chris Collins. I'm a newly associate professor at the University of Ontario Institute of Technology, and my research focus is on information visualization, but also meets HCI. As John mentioned, I was working for the last couple of years on a toolkit for teaching multi-touch software design, but it's nice to see it also being used in research. And I've also done some work in interacting with time-varying visualizations using touchscreens. Thanks.
Hi, my name is Gregory Lee, and I'm part of the IT technical support team for all of TNR, and that includes managing and supporting these devices that a lot of these researchers use.
Yes, a big thanks to Gregory and the rest of the tech support team that have gone into putting this huge production up.
Hello, I'm Neil Emerton. I work with the Applied Sciences group here at Microsoft, and I'm an optics guy by background, currently trying to enhance the interactivity of various display technologies by using a kind of variety of sensors and optics technologies.
Hello, I'm Aaron Quigley. I'm the director of the St. Andrews Computer-Human Interaction Research Group. We have 5 faculty, 14 PhDs, 14 MScs, same number of undergrads and interns working with us. I work primarily on novel interaction, information visualization, and ubiquitous computing, and the crossover, and I'll be talking later on.
Hello, my name is Nathalie Henry-Rich. I'm a researcher here at Microsoft Research. I do mostly research in information visualization, and I'm interested in those large surfaces for exploring information and also presenting insights and convincing people.
Hi, my name is Phil Bachman. You just saw me.
Hi, my name is Jim Stevenson. I work at Microsoft. I was a program manager for our 55-inch Surface Hub. I'll be leading being a program manager for our next generation product as well. So appreciate the opportunity to be here and see all the great innovations and see what types of experiences are possible for our next products.
Hello, I'm Rick Yang. I'm from University of Kentucky. I'm a faculty there. My research area is in computer graphic and computer vision, in particular about tile collaboration, tile presence, and holoportation. I'm going to talk about my research right after lunch, I believe, right?
I'm Curtis Wong, and I'm a principal researcher at Microsoft. Led the vision for Worldwide Telescope and something called PowerMap, or 3D Maps now in Office Excel. I work with Dave Brown. We do a lot of work with something called NuiGraph on the PPI and the Hub, as well as other 3D visualization on other devices.
Hi, I'm Hari Subramaniam. I'm a PhD student at the University of Michigan.
This summer I'm working with Curtis, Dave, and Steven, like looking at interactivity for holographic visualizations or 3D visualizations. Thanks.
Hi, I'm Chris Haverty at Microsoft here in the Surface Hub group. I'm the program manager that brought out the 84-inch Surface Hub product. It's really fun to see all the neat and interesting things that you all are doing with the product, and I'd love to hear what you love and don't love about it so we can be even better in the next generations.
All right, so, Andy's introduced during his session. So we'll break for lunch.